Good morning, students. Today we'll be discuss the next concept called electric field. So the next concept is electric field. So how can you understand this electric field? Just we can discuss this. You see, if you take two bodies, let us suppose a body of charge Q here. This is a body of charge Q, positively charged, and at certain distance we placed a charge which is Q naught, positive charge which is Q naught. Let this charge is A, let this charge is B. Now already from Coulomb's law we discussed that if two charges were there, one charge can able to exert a repulsive force on the another one. The same way this charge Q will exert a repulsive force on Q naught, that is we take it as a F naught. Now this force we can treat as so we can think about this force as an action at a distance force. This force can be think as a action at a distance force. Why we are calling this as a action at a distance force means that is action at a distance force meaning is that is the force which acts in a empty space and without any physical contact one body can able to exert force on the another one. So a force, this is an action at a distance force meaning is a force which acts in empty space and which can exert a force without any physical contact and which can exert a force without any physical contact. Generally in mechanics, when you are exerting a force over the body, usually what we discussed, so when you are applying by touching the force over the body, then the body will be displaced. But this is the force, even there is no physical contact, one will able to exert force on the another one. So that's why this is, we can call it as a action at distance force. So you can observe the same thing you studied in the first year also, that is gravitation chapter. See, the sun will able to exert gravitational force of attraction on the earth. So but there is no physical contact between these two, but the sun can able to attract the earth. So how this is possible means what is happened there, the sun can able to exert a gravitational field around it. In the gravitational force field earth is existing, so that gravitational field will attract the earth. In the same manner here this charge is able to attract this one means what you may ask the question, so what will be happens this is how this charge, this is experience force, how this charge can able to sense the presence of this charge. This is far from it, but how this charge can able to sense the presence of this charge, that is the question we can arise. How charge Q naught sense the presence of another charge. So this can be understood like this. What will happen is here we can say that this charge, whatever the charge is there, no, this charge will be creates like that, it is creates an electric field like this. It will be creates up to certain region. What happens means it will creates an electric field. So the space around it. So one charge is there, it will develop an electric field around that space up to certain extent. What will happen means a second charged particle is placed in this field. It is not directly interacts with this one. First it responds to the field, whatever the field produced by the this charge. Okay, so that is the thing will be happen means what will here is electric field is acts as a mediator. Electric field acts as a mediator, and that a mediator will exert means it is it can able to exert the force on this one by this charge. So we can say the electric field means it is a space. We can say it is a space around the charge in which where its influence can be felt by another charge. For example, you took here, you taken this is around this charge, there is a space around this charge in which if you brought any other charge in this premises, what happens, the charge can be influenced by this one. Means influenced by this one means if you brought this as a positive charge, this is experiencing repulsive force. Let us suppose if I brought here in this field, so if I brought a negative charge minus q, what happened means this will be experienced, it is experience its influence and it will be attracted by it. So like this, any charge is there around that charge, what happens means up to certain extent its influence will be there, and if you brought it any other charge in this vicinity, what happens means that charge either experience force of attraction or else force of repulsion. Suppose if you positive charge is there, if you brought positive charge in the vicinity, it will experience repulsion. So this is positive charge. In its vicinity, if you brought it a negative charge means it will be what experience attraction. Like that you have to understand that electric field is just like a gravitational field. If a mass is there, around the mass what is there? Gravitational field it is there. In the gravitational field, if you brought it any other point mass, it will experience attraction. So there only attraction. But in the same case here, a charge is there, around that charge up to a certain extent, it's the charge, it will influences. What is the meaning of influences in the sense? So if any charge, if you brought it in that space, so this charge it will attract or it may repel it. This is the thing will be happens. This is the region, this space around the electric charge where its influence can be felt by another charge is called as the electric field. Okay, understand? So next we can go for the electric field intensity. So okay, so what is an electric field intensity? Now we can discuss it. Here, electric field intensity. Electric field intensity. So let us take a charge as you taken in the previous case. The same manner here we are taking a charge Q. So we discussed if the charge is there around the charge up to certain extent, what will be there? Its influence will be there. So this charge up to this extent, its influence is there. What is this region we called as a electric field region? Okay, so in this electric field region, so you placed a point charge. Let us take, if you take a point charge, positive test charge we can call. Again you may ask, here we placed a test charge at point P. So Q0 is a test charge. So you may ask, what is the meaning of test charge? The test charge, and it is we can call it as a source charge. What is the meaning of source charge? Means it will produces an electric field around it. It is called as a source charge. And test charge, we are locating at a distance test charge. What is the meaning of test charge? Means it is a small positive charge. So this charge very small in magnitude, but why we are taking like that? It should not influence the charge distribution of the source charge. Even it should not influence the electric field at this point. That's why what we are going to take is the charge test charge. It is a very small magnitude of charge. Okay, so it will not influence the charge distribution on the source charge. Why? Because this charge distribution changes, the field obviously changes, then we cannot able to find the electric field at a given point. That's why what we have to take here is we should take a very small magnitude of charge. That is called as a test charge. So test charge is a positive charge, a positive or negative. We can also take a positive charge which is small, very small in magnitude, very small in magnitude. Okay, and and what happens here is it has a negligible effect on the field around that point, and it is does not, we can say it does not affect the, it is does not affect the field. Okay, so field around this point, field around this point. So this is we can call it as a what, test charge. Now according to the definition, means electric field intensity and electric field strength also we can call. What is the electric field intensity? Electric field strength means just we have discussed this charge is there, and in this field electric field we located a test charge. Okay, this test charge, what will happen? This test charge will experience force, and this force experienced per unit test charge at this point is called as the electric field intensity. So electric field intensity at a given point is nothing but, so electric field intensity at a point P is electric field intensity at a point is the force, you can write force exerted per unit positive charge. So we can say the force then we can write like this. This is the intensity of electric field. The strength of the electric field at a point is defined as the force experienced by the unit positive charge located at this point. Force experienced by unit in the sense 1 coulomb test charge we are taking, unit unit test charge placed at that point. So we can write as electric field intensity at a point P means E equal to, we can write E bar equal to force by charge Q naught. Here you know force is a vector quantity like that, that's why electric field intensity is also be a vector quantity. And we are telling here, we are taking in the denominator as a what, test charge, and we define the test charge also. Test charge means which is very small in magnitude. So correctly means you have to speak that in this test charge, if it is large in size, what will happen? I told you this the charge distribution over the source charge will be disturbed. That's why electric field intensity also be going to be disturbed. That's why clearly telling that this charge should be very small. So to indicate that, we can write like this. To exactly define the electric field intensity, we can write here Q naught is vanishingly small, means very nearly zero, vanishingly small means almost zero, we can say. That's why we can define exactly, we can define electric field intensity bar is equals to what, limit Q naught tends to 0. You know the meaning of it. So its value is nearly equivalent to 0, tends to 0 means. So F bar by Q naught. This is what exactly we can define the electric field intensity. So the electric force per unit test charge acting on a the electric force per unit test charge acting on a what kind of vanishingly small point charge. Okay, test point test charge, that is called as the electric field intensity. So electric field intensity we discussed, it is a vector quantity. So E bar is a vector quantity and its direction is along the direction of the force. Its direction is along the direction of force. Along the direction of force. Direction of force you can write. And about the units, you can say here force by charge. So force is the unit says Newton, SI unit, charge is Coulomb. So unit you can write units in SI. So electric field intensity unit is F is equals to E equal to F by Q. Therefore Newton per Coulomb. Or we have one more unit, what is volt per meter, that is in potential chapter, we will be discussing. So this is the about the electric field intensity. Now we are going to discuss the electric field intensity due to a point charge, an isolated point charge. We will discuss about it. So the expression for electric field intensity, electric field intensity due to a isolated point charge. Due to an isolated point charge. Let us take a charge Q, and what happens here at point A, we'll take a, suppose here we took a charge Q. Okay, this is at point A. So at a distance r, I want to find the electric field intensity of this charge Q. Okay, so at a distance r we are taking. If you write the unit vector means it is r cap, we can write. Here at point P, we are taking a test charge. You know the meaning of test charge. It is very small in magnitude, and unit means it is 1 coulomb of positive charge. Okay, so here we know this charge will be exert force over it. What is the force exerted by this charge on this one is the force exerted by charge Q on test charge Q naught. Charge Q on test charge Q naught. That is, we can write as that force F is equals to F bar equal to, we know if these two are located in vacuum or free air, okay, suppose we took as in air. Now the force is 1 upon 4 pi epsilon naught into product of the charges, capital Q into small q by distance. Distance is r square. In vector form we are writing, so along the direction of along, we can also say r cap is along the direction of AP, along AP. Now electric field intensity, just now we discussed electric field intensity is nothing but the force experienced by unit charge. The force experienced by unit charge, a test charge, we can write as the electric field intensity is nothing but intensity at point P, that is electric field intensity E equal to force experienced by unit charge. So force experienced by unit charge is that is what electric field intensity already we discussed. Now the force is already here we found, that is 1 upon 4 pi epsilon naught into q naught by what, r square into r cap by q naught. Then these q naught will be gets cancelled. Then we can write electric field intensity E equal to 1 upon 4 pi epsilon naught q by r square into r cap, and its direction we can say along AP. Okay, see, if this charge, if it is positive charge, that's why what the electric field intensity is, direction is away from it. If suppose if this is the negative charge, means the electric field intensity direction, instead of repulsive, it will be attracted. So that's why what happens, the direction of electric field intensity is along PA. If the charge Q is negative, if the charge capital Q is negative, so what will happen here, the electric field intensity direction is electric field intensity direction is along what, PA. Direction is along, we can write PA. Okay, that is the thing you can understand. So later what we discussed here is so electric field intensity expression is this is the thing, you have this expression, you see here epsilon naught we wrote. What is this importance, we discussed in force case also. Epsilon naught is nothing but the permittivity of free space. Here we taken as air, that's why what we wrote here, electric field intensity means 1 upon 4 pi epsilon naught into q by r square. But instead of air, if it is this is we placed here, any medium is present. So between q and q naught, if medium is present between q and q naught, if medium is present, what will happen? So we'll take the, instead of epsilon naught, we'll take the epsilon, that is epsilon is the permittivity of medium. That time the expression we can write as a E bar is equal to, this is we can write vacuum and it is in medium. So medium is equals to 1 upon 4 pi epsilon. So here vacuum means epsilon naught, but permittivity of the medium is epsilon into q by r square into r cap. And epsilon we can write as a epsilon naught into dielectric constant. Epsilon is equals to k epsilon naught. But if you write electric field intensity in a medium is equal to 1 by k into here 1 upon 4 pi epsilon naught q by r square into r cap. This is nothing but electric field intensity in vacuum. So electric field intensity in a medium is equal to 1 by k times the electric field intensity in vacuum. That is like same as force we discussed, the force in a medium is 1 by k times the force in vacuum. The same electric field intensity in a medium is 1 by k times the electric field intensity in vacuum. That is the thing we can say. Next, electric field intensity due to system of point charges. Here electric field intensity due to system of electric field intensity due to system of point charges. So instead of here we took only one point charge and we are finding the isolated point charge, and then we found the electric field intensity due to one isolated point charge only. But we have system of point charges. Now many charges are there. So due to many charges, we want to find at any one point electric field intensity, means that is we should take the electric field vector sum of the electric field intensity due to all the charges at that point. So that is how can you understand, means just we can take one example and we'll be generalize it for a number of charges. Let us take we can simple case in the sense we'll take two charges and we'll tell you how you can find the electric field intensity due to those two charges at a given point. From that you can able to generalize the electric field intensity due to system of point charges at a point. Now if you take here in a coordinate system, I have two charges. One is what, at a distance r1. Here I have a charge q1, okay, as well as here we have at r2 distance, r2 bar. Here we have a q2 charge. Like that I have two charges. So due to these two charges, I want to find the electric field intensity at this point P. Got it here? So at this point P, the point P position vector is r bar. So at this point P, due to these two charges, electric field intensity we need to be determined. So to going to be determined, just I'm taking that. We know these two, if you line join it, this is what we can call it as a, this is you take as a rp bar. Why? Because this is the point position vector of P. That's why rp bar we are writing. So this is we can write as a rp minus r1, that is rp1 bar, that is rp bar minus r1 bar. And this charge having electric field intensity at point P, which is a positive charge, no? So it is away from it. This is the direction of electric field intensity E1. So at point P, electric field intensity at point B, that is what, due to charge 1. Understand? In the same way, if you line join these two charges, and this is nothing but rp2 bar, that is rp minus what, r2 bar. And due to this charge here, electric field intensity is away from it. Due to this charge, electric field intensity away from it, that is electric field intensity at point P due to the second charge q2. Now the resultant of these two we need to be determined at point P, the resultant of these two. To determine this, what we need to do, so we have to be construct one parallelogram. Okay, so now we constructed one parallelogram, and this parallelogram, if you join the diagonal, this diagonal, what it will give is the resultant of these two. Here the resultant electric field intensity E is equals to, that is E P1 bar plus E P2 bar, that is E1 EP1, and this is EP2, and the diagonal gives the resultant of these two, no? That's why we wrote E equal to EP1 plus EP2. So now we can write that EP1 bar equal to 1 upon 4 pi epsilon naught Q1 by what, RP1 square RP1 cap, the direction of this RP1 direction. And EP2 is equals to 1 upon 4 pi epsilon naught Q2 by RP2 square RP2 cap. This is the vector. Now resultant at point P, the resultant electric field intensity, at point P is E equal to the resultant of these two. Vector sum of these two means, that is we can write as a EP1 bar plus EP2 bar. Then E bar equal to, we can write 1 upon 4 pi epsilon naught what, Q1 by RP1 square RP1 cap plus Q2 by RP2 square into RP2 cap. If two charges were there, the electric field intensity at a point P is the vector sum of the electric field intensity to these two charges we taken. In the same manner, if what is there, system of point charges is there. So the same way, The same way, if system of charges are there, system of charges q1 comma q2 comma q3 etc etc qn. So the same way, if the system of charges is there, so the electric field intensity at a point P due to these charges, the electric field intensity due to these charges at point P. How we can write? If two charges are there, we wrote 2. In like that, if n charges are there, means we can be generalize it by taking the n charges. Then we can write E bar equal to 1 upon 4 pi epsilon naught q1 by r p1 r square r p1 cap plus q2 by r p2 square r p2 cap plus q3 by r p3 cap, and so on up to n. We can take it up to n in the sense qn by r pn cap. So like this, the electric field intensity to the system of charges nothing but the sum of the electric field intensity due to the all the charges at the given point. So this is the thing you can say. Next we can go for the electric field lines. What is an electric field lines? That is, we will be discussing here. Electric field lines See, electric field lines is an imaginary line. Okay, imaginary line or a curve such that at any point, if you draw the tangent gives the direction of electric field intensity. So how can you understand this? You may ask that if a charge q is there, this is a positive charge we took taken. So if you take isolated positive charge, so isolated positive charge means unit charge in the sense plus 1 coulomb charge if you taken, what will happen means it will be freely move in this direction. So this will be in which direction it will freely move, that line join it is moving like this. Then if you line join this line, we can call it as a what? Electric field lines. See, we discussed electric field is possible. The electric field is an imaginary thing. The imaginary lines we can draw like this. How we can draw like this means in the nearby the charge, if you place a 1 unit test charge, the test charge in which way it will freely move, that path if you follow, that path gives the electric field lines. So that may be a straight line, that may be a curved line. And what is the important of that is, if you take the such that if you draw any tangent at any point of this electric field line, suppose we took here the electric field line is a curved, because electric field line may be curved, may be straight line. Here single charge is there, straight line came, but combination of charges we taken means a curved straight line will not come, curved lines will come. So if a curved line is there, if it is a point P is taken, if you draw a tangent at this point, here this tangent will give the direction of electric field intensity at this given point. Similarly here a Q is R is there. If a point R is there, here it will give us the, if you draw the tangent here, it will give us the electric field intensity at this point. So you can understand this one in the first year concept, that is streamline flow is there. So streamline flow means imaginary lines we drawn at any point. If you draw the tangent for the streamline, it will give the velocity of the fluid flow. So in the same way here also, it is an imaginary lines. This may be straight line or curved lines that can be drawn by following the test charge, which is freely move, in which direction it is freely move. That path we follow, we can draw this, and such that at any point if you draw the tangent of this electric field line, it gives the electric field intensity. And few of the electric field lines, how it is possible for different charges, we can discuss it here. If a single positive charge is there, isolated positive charge is there, the electric field lines are normally away from it. This is the electric field lines. And if your negative charge is there, if it is a negative charge is there, the electric field lines is towards and normal to the body, normal to the point charge here. So it is towards it. Positive charge means it diverges away from the positive charge and converges towards the negative charge. And if you take it a dipole in the sense the two are like charges if you taken. Suppose if you take here a plus q and same charge if you taken, both will be exact the field lines. If isolated charges are taken, you will get a straight lines which is diverging outwards or converging inwards. But a pair of charges is taken, there is a repulsion is there. That's why the electric field lines you can draw like this. So these are the electric field lines. Same way here. This is the electric field. If you take a dipole means we will be discuss it. It is an two equal and opposite charges separated by certain distance is called as the dipole. Here one is a positive charge, another one is a negative charge is there. These are attraction is there. The charges diverges from the positive charge and converges at the electric field and diverges from the positive charge and converges at the negative charge. Okay. So that's why what happens here, diverges from positive charge and ends at the negative charge. Like this diverges from the positive charge and ends at the negative charge. So we can say like this, diverges and converges at the negative charge. This is the thing you can understand. So like this, these field lines you can write. See, I told you at any point if you draw the tangent gives the electric field intensity at that point. So if you take a charge here, if you draw the tangent, this will give the electric field at this point. And here if you draw the tangent, this will give the electric field at this point. Here if you draw the tangent, it will give the electric field at this point. Like that, any point, tangent if you draw at any point, here if you draw the tangent at this point, it gives the electric field intensity at this point. Like this, the tangent of this electric field lines, imaginary field lines, at any point if you draw the tangent, it will give the direction of what? Electric field intensity. And here the main important thing is the properties of electric field lines. The properties of electric field lines is, first one is the electric field lines diverges from a positive charge and converges at the negative charge. So here electric field lines diverges from positive charge and converges at negative charge. And one more thing is there will be open lines. Open lines means if you have two bodies are there, electric field lines are open lines. So electric field lines are open, what we can say is a lines means if you take a charged bodies, two charged bodies, I told you if you take one positive charge, another one is a negative charge. The electric field line diverge from a positive charge and end at a negative charge. They won't be passed inside the body. Means that begins from the positive charge and ends at the negative charge. That's why they are called as a open lines. Like that you can understand it. Okay, and they won't be passed into the conductor. That is another point is we know at any point of the if you tangent at any point gives the direction of electric field intensity. The tangent drawn at any point gives the direction of electric field intensity, direction of E. And one more important point is no two electric field lines will intersect with each other, See, this is important point. No two electric field lines will intersect with each other in the sense. Here, will intersect with, no two electric field lines will intersect with each other means two lines if they intersect, what the thing will be happening is like this. If two electric field lines are there, they intersected. This is the point of intersection. So in this point of intersection, if you draw the tangent, this is one tangent, this is another tangent. At the same point P, the electric field is having two different directions. This is one electric field direction, this is another electric field direction. So at the same point, electric field doesn't have two directions at the same point. So that's why, so it is not possible. That's why what we'll say, they will not intersect with each other. That is the point you have to be understand. And no two electric field lines will intersect with each other. This is the thing. And if the electric field lines are crowded, like here, you can understand. If electric field lines, like I am taking the like this. Here the electric field crowded. Here electric field is far from each other. So here electric field is crowded. Here electric field intensity is E1 if you taken. Here electric field intensity E2 is taken. Where here crowded, here farther away. Where electric field intensity crowded, their intensity, the field strength is more. Where electric field lines are farther away from each other, their strength is less. Here more it is crowded at point A. Here point B you taken. At point A lines are crowded. At point B lines are farther from each other. So we can write electric field intensity E1 is greater than the electric field intensity E2. And you can also say uniform electric field. If the electric field lines are equally spaced, then we can say as a uniform electric field. Non-uniform in the sense that is electric field lines are not everywhere the electric field lines are going to be changed. So here electric field is different, here electric field is different, like the electric field point to point changes. This is, we can call it as a non-uniform electric field. And one more important point, that always electric field lines if you take a charge, electric field lines are normal to the surface. If you take a charged body, spherically charged body, electric field lines is always normal to the surface of the body. Okay, if you take a positive charge here, electric field lines are always normal to the surface of body. This point is important also. Electric field lines normal to surface. So these are the thing about the electric field lines. Next session we will discuss the electric flux. Okay, so the next session will go to the discussion of electric flux and its application and objective points. Okay, thank you.